let's cover section 6.2, exploring graphs of systems of linear inequalities. So on 6.1, we just did single lines. 6.2, when it talks about systems of linear inequalities, all it means is now you're going to have more than one line. Okay, so two or more lines. Okay. And so the keep in mind here, first of all, says that you're going to graph all the inequalities in a system of linear inequalities on the same coordinate plane. So this is a horrible picture over here, but it does show you that we're graphing this line and graphing this line, okay? And so this is a system of linear equations. This is the dark part here showing that's where the overlap is. And the overlap is actually the solution. So it says the area in which all the solution regions overlap represents the solution set to the system. It means that any ordered pair in the shaded part will be an answer for the two equations. And it says, for example, this graph shows the solution region to this system. So it says y is greater or equal to x. So again, let's start over. Not the nicest graph, but let's see if I can help you a little bit. Here is my x-axis. Oh, that's horrible. It's too thick. Like that. There we go. Here is my y-axis, which I'm going to make skinny again. There we go. Okay. So the equation y is greater or equal to x is this line right here. This one, y equals x. Black's not helpful, I know. I'm going to make it a different color. And I make it green. There we go. That's the line of y is greater or equal to x. And if I were to shade that, if y is greater to x, that's on this side. This is where y is greater or equal, my bad, y greater or equal to. That's why I have a solid line, okay? And it's in the set of real numbers, so I can shade. So I want everything above this line, above the green line, okay? Everything above the green line, including touching the green line because it's a greater than or equal to, is the solution for this, okay? Now, this line, y is less than or equal to 4, is this line. It crosses the y-axis at 4. I want a line. There we go. Right here. So that's where we cross the y-axis at 4. It's a line that crosses. Can you see that? There we go. It's the line that crosses the y-axis at 4. Scooch it down a little. And then it says y is less than or equal to 4. So it has to be everything underneath. So I'm going to take a different color of highlighter, and I'm going to shade everything in underneath, because anything under this, any y underneath the line, will satisfy this equation of y is less than or equal to 4. So it's a solid line because it's less than or equal. I can shade because it's in the set of real numbers R. So hopefully you can see now that in this section here, there's overlap right here. Here, here, and here is the overlap, meaning any ordered pair that you pick in this section will be true in both equations. So what if we picked this? Where's my pen? What if we picked this ordered pair right here? This ordered pair is -3 and 1. Okay, remember this is the x and this is the y. So if I plug it into this question, 1 greater or equal to -3 is true. Over here, y is 1, 1 is less than or equal to 4. That's true. Anything in this region will satisfy both these equations. Okay? The solution region for a system of linear inequalities can be discrete or continuous, and it may be restricted to certain quadrants. So it's going to be, in this example, remember it was continuous because I had the set of real numbers. It might be discrete if you have integers or whole numbers. And then it might be restricted to certain quadrants, because if this said in the set of whole numbers, I'd only be talking in the first quadrant. This is important. If the solution regions do not overlap, you don't have any solution, because it has to satisfy both of the sections, not just one. All right, so let's try an example, and this one's different. It's the set of integers. So it says, graph the system of linear inequalities and justify your representation of the solution set. My bracelets, man, are making solution a hard word to say. All right, we need a boundary line for both of these. So the boundary line for x plus y, I'm going to make it equal 5. So I'm going to have y equals negative x plus, I really wish my pen would stop doing that, negative x plus 5. I don't know if you can tell what that is. Negative x plus 5. I have to slow down my writing. Okay, my other one says x plus 3y. To make my boundary line, I'm just going to make it equals 0. So 3y equal to negative x, because I'm going to take that x and put it to the other side. Then I'm going to divide by 3. So y is equal to negative 1/3 x. Do you know where that 1 came from? It's the 1 that's sitting in front of the x. So these are the two lines I'm going to graph. Y equals negative x plus 5 and y equals negative 1/3 x. So let's go ahead on the graph and draw them. Okay, y equals negative x plus 5 and y equals negative 1/3 x. Okay, y equals negative x plus 5. Remember, in the form of y equals mx plus b, meaning my y-intercept is 5, my slope is negative 1/1. So down 1 over 1, down 1 over 1, down 1 over 1. And you might be able to see that I actually already have this line graphed. Okay, so this red line here is y equals negative x plus 5. Remember the original question? It was a less than or equal to. So I'm going to have a solid line. Okay, so that's my first line. My second line is y equals negative, you can't even tell, this is horrible writing. Y, I'm going to write slower, y equals negative 1/3 x, right? Y equals, yes, negative 1/3 x. Okay, now notice in the form of y equals mx plus b, I don't have any b, so make it 0 because there's nothing there. Therefore, it crosses my y-axis at 0. My first line keeps disappearing after every time I go off the page. Okay, my slope is negative 1 over 3. So down 1 over 3. Down 1 over 3. Down 1, I'm off the graph. Okay, so you could line those points up and have your second line. Okay, now it's dashed because look at my original question, it's a greater than. Okay, so first line solid because it was less than or equal, second dashed. Okay, so now think about this. Because I have two lines, think about the zones that I have on my graph. I have here, I have here, I have here, and then if I continued off my graph, I'd have this section in here. Now remember that my solution set is the set of integers. So let's go back and think about my original question. I can't remember anything, so give me a second. I'm going to copy this and put it onto my other page so I can keep looking at it. Cool, I can just copy it. And I can paste it. Okay. All right, so remember I said that I divided my graph into sections. And what I have to do is I have to figure out which section is my answer. And so just randomly, I'm going to start with this section here. Okay, I could start here, I could start here, whatever. I'm just going to start here. And what I'm going to do is I'm going to check an ordered pair that's in this section. I'm going to test it in my original question. And if it's true, then this zone is true. And so I'm going to pick a nice, simple ordered pair This one, okay? I can pick anything in here, but I'm going to test this ordered pair of 0 and 2. And I'm going to see what happens, okay? Remember, x is 0 and y is 2. So in my first equation, x plus y has to be less than or equal to 5. So x is 0, y is 2, and that has to be less than or equal to 5, which is true. All right, my second equation. X is 0, y is 2, and it's x plus 3y, so it's 3 times y, which is 3 times 2, which is 6, has to be greater than 0. 0 plus 6 is indeed bigger than 0. So both of these ordered pairs satisfy my solution. So it does mean that this section here, everything in here, is my solution. Okay? So what if I had tested something else? So you're probably thinking, well, is the first section you choose always your answer? But it's not, because what if I had tested an ordered pair in another section? So what if I had decided to go, let's test here, and that is 1 and negative 2. So into my first question, I have to have x plus y is less than or equal to 5. Well, 1 plus negative 2 is indeed less than or equal to negative 5. That works. But what about the other one? It has to be x plus 3 times y has to be greater than 0. This would be 1 plus negative 6, which is negative 5. Negative 5 isn't bigger than 0. So even though it satisfies the first question, it doesn't satisfy the second, so it's not the solution. And I'm not going to do it, but if we were to test something over here, it wouldn't work either, because it wouldn't satisfy them both, okay? So remember, here is my answer, but I hope you were wondering about this, okay? Because they are in the set of integers. So remember how I highlighted this section? Remember, if you highlight a section, you're saying every little ordered pair, okay, that you can come up with, not necessarily just these nice ones that land on numbers, but anything in here will work. And you know what? They won't, because unless you're on one of these intersections, it's not an integer. So you actually can't shade the region. This is where you gotta stipple it. So your answer should look like this. And it's a bit annoying, I know. And you can do a few and then I'll know what you mean. But you have to stipple it. You have to put dots only on ordered pairs, like this. So your solution is anything that's a nice ordered pair in that zone. Okay, by now you're like, okay, I'm tired of doing little dots. So if you kind of just put arrows, I get it. Okay. Now remember how this line was dashed? So I've got this ordered pair here, but I can't put it in my solution because this dashed line means that it doesn't include it. It was greater than, not greater than or equal to. So anything on this line can't be included. So I can't include this dot, I can't include this one, or this one. But remember how this is a solid dot? That solid dot came from less than or equal to. So you know what? I can dot everything on that line. And if I ask you to do this on a test, that's what I'm going to be looking for. So nothing along this dashed line can be included, but everything on the solid line can. Okay? So please come and ask questions as needed. I know this is a bit of a difficult topic. But once you get the hang of it, it's not so bad. So come and ask questions as you need. Good luck.